Hello everyone. Today we will see topic 8 static structural analysis. So what is static structural analysis? It determines the effect of steady or the static loading conditions on a structure while omitting inertia and damping effects such as those caused by time varying loads. So a static structural simulation determines the effect of steady loading on a structure. Stress, strain and deformation of a structure can be studied under a range of loading conditions. This helps to identify weak areas with low strength and durability at the design stage and avoid the expensive failures. So there are three stages for the static structural analysis. First stage is the pre-processing, second one is the solution, and the last one is the post-processing. We'll see all three processes in a practical way. So we will drag and drop the static structural into the project and we'll give the name of the project. So we have one question for the Allen key range. So we are going to cover it today. Static We'll see the problem first. So the problem is an Allen range 10 mm across the flats is torqued by means of a 100 Newton force at its ends. Later a 20 Newton downward force is applied at the same end. At the same thing, retaining the original 100 Newton torquing force, the objective is to determine the stress intensity in the range under these two loading conditions. So this is the problem requirement. We have to create an Allen key using a sweep command by giving this dimension, and we have to apply the one force of 20 Newton and another force of 100 Newton at the edge of the Allen key. Now we will apply the material condition. So we are taking the structure as steel as a default material for our project. Then we will go back to our project. Then we will create a geometry of the Allen key as per the problem requirement. So in the geometry tab we will create the Allen key. So first we will define the profile. We'll give the dimensions to it. So we have created the profile. Now we have to create the path. Here you can see we have created an Allen key with the same dimension. We have given this length as 20, this height as 7.5 mm. and this is the hexagonal profile. Now we will start with the third step of model. Double click on this. Now we will first check the material. It should be structural steel. Yes, it is right. Then we are going to apply a mesh. Generate mesh. So this is the default mesh that we have applied. If you want, you can change the size from here. So we are going to give it 0.5 and click on update. Now here you can see, now it's looking like a fine mesh. Okay. Now we have to apply the condition. So we have to apply first the fixed support. So we are going to apply on this face as a fixed support. Then we are applying loads. We are going to apply force on the top surface of magnitude 20 Newton. Change the direction So our force is applied. Now we have to apply one more force as per the problem requirement. So we are going to apply now on the edge. So I am selecting the edge, this edge, to apply it. Force of 100 Newton. I am going to change the direction. Second force is also applied of 100 Newton. Now we can see one is fixed support, one is the force in downward direction of 20 Newton and another force on the edge of 100 Newton. Now we are going to apply the solutions. So first of all we want total deformation, equivalent of the von Mises stress, von Mises strain. We want the deformation in directional. So here we can define the in which direction we want. I want in Z axis direction. Now we are going to click on it and click on solve. So it gets solved. Now we are going to see the results of total deformation. So this is how deformation is going to carry forward through this. Now we are going to see in an analytical way. So minimum deformation is 0 and maximum deformation is 1.7391 e raised to 6. Now the equivalent stresses, here you can see elastic strain and the directional deformation in Z direction. This is how our Allen key is going to deform in the Z direction.